Okay, hello students. Here, this is the lesson number 2.1, and the goal of our lesson is our objective for this lesson, and especially this lesson will be on probability. Probability basically means chances. We'll see as we progress. So the learning target is solve counting problems using. So we're going to know what is this addition principle, multiplication principle, and solve counting problems using a new vocabulary word permutation involving n objects, and also solving counting problem with combinations. So these are the two things we are going to learn. What is permutation, what is combination as we progress. I'm gonna go straight away to the meaning of addition principle. So what is addition principle? According to the addition principle, if one event can occur in m ways and the seventh event can with no common outcomes can occur in n ways, then the first or the second event can occur in m plus n. Now, what does this basically mean? Let me suppose this is a bag, and this bag has contains the blue marbles. There are four blue marbles, and let's see there are uh, five red marbles. You can see these are four. These are four, and those are five. So this blue marble, there are four. So there are four possibilities to when you pull out a ball. Let's see if I want to pull out a marble from this bag. So we have four chances to possibilities to get the blue marble, and there are five five chances to get. So that n that you see here, m is four possibilities, and that n that you see is there are five chances to get a red. So then the first, either the first or the second. That means when you pull out a marble from this, so either it is going to be the red or the blue will be together. So that's what it means. Because there are four, there are four blue, and there are five. So it is four plus five. So either the marble is going to be blue or the red is going to be four plus five, which is nine, and that is called addition postulate. Now let's see. So look, let's take an example. There are two vegetarian entry options and five meat entry options on a menu. What is the total number of entry options? So that means this is the menu card, right? So this is the menu card, and there are vegetarian, there are two, one and two. These are veg entries, and there are five meat entries. So there are five meat entries, and I will put it like a bullets. Okay, these are five, maybe one, two, three, four, five. So that means to select either veg. So this is what I'm saying. Either if you select vegetarian entry, or you may select non-vegetarian entry. So we have together how many are there? Options is, so the total. What is the total number of entries? So it's going to be two vegetarian plus two five meat entry. So the total will be seven entries. So when I say seven entries, either it is going to be two vegetarian or five. So it's going to be total number of seven, and that's what this addition principle means. So example number two, I want you to pause the video and see if you can do it. It's not difficult because this is just kind of just adding, right? A student is shopping for a new computer. She is deciding among, so there are three desktops. That means these are like computer lists. There are three big computers. So these are three computers. These are desktop. Okay. And there are four laptop computers. So when you say laptop, basically means this. So there are four like this. See, this is laptop one, two, three, four. So the question is, so four, these are four. I'm just doing it quickly for visual understanding. What is the total number of computer options? So the total number of computer option is this three together plus this laptop. So it's going to be three plus four, which is seven uh, possibilities of either the when you when you select from this three and four laptops. These are four. So what are the your option to select? Either you have three. So the question is the total number of computer options. So these are desktop and these are laptops. So together there will be 3 plus 7. 3 plus 4 is 7 computer options. I hope that takes care. Let's go to the next. Okay, look, suppose that this is example number 3. Suppose at a particular restaurant you have three choices for an appetizer. So these are the options. So when you go, you can pick either you can select soup or you can select salad or you can select breadstick. So this is your starters, the starters. Okay. And after that you have, and then you have five choices for the main course. And the main course is once you make the first option, you have three options for soup, salad, and breadstick. But once you choose one of these, let's say you select five, that means we can pick one of these five main course. That means this is the once you select soup, either you can pick a hamburger or you can pick a quiche sandwich, okay, or you can pick a quiche, I don't know how you say it, or fajita or pasta. So the question is, that means now this is only if you select the soup as the first. So each time you select the entry, the main end, the first entry, like starters, then after that you have those five options. Now right here you can see together these are. So if you select soup, let's see if you are selecting soup, then you can select hamburger, then you can select sandwich, quiche, fajita, and pasta. So you have five options. So the first option you have three, one, two, three, and then and for each one you have one, two. Likewise, so selecting the soup, you have five options here. Now imagine if you had to select the salad, then again you will be having this another five option like this. Eh? So it's going to be hamburger, sandwich, quiche, fajita, and pasta. So again, you have five options. And if you had to select, let me use some other color, let's see, blue, breadstick. Now breadstick also you'll have five options after it's like this. So it's going to be either hamburger, sandwich, quiche, fajita, and pasta. Clearly, you can see these are again another five options. So altogether, how many options did we get? Is you had first five option, again five option, and again five option. And 5 plus 5 plus 5 plus 5. Altogether, we have 15 options. So that's the question. If you are allowed to choose exactly one item from each category for your meal, how many different meals option do you have? So what are the variety way of possibilities to pick the one from the three first and then the five? And then one way you can do is there are different, will we understand there's something called fundamental principle of counting. So what is fundamental principle of counting is basically you don't have to draw everything, and fundamental principles of counting says, remember this last time we have 5 plus 5 plus 5. So there are three 5, right? 3 times 5. And we have seen, sorry, so 3 times 5, and that is 15. So all you do is, this is the first three. There are three fives, 1, 2, and 3. So this is 3 times 5. So because there are three 5. So that means all you do is the first case, there were three options. So, and then after that, you had five options. So what does the fundamental principle of counting says is, you instead of drawing and showing all the work, we can directly say then how many different options. So the first, so for the appetizer, so the option to select, So option to select, so how many ways can you select an appetizer? So you have three options, right? And how many ways you can select the main course? You have five options. So that means the total number of ways, total, total, diff, total meals option. So that means total meals option is if one, so if first part can be done in three ways. So it is like it's like a formula we are going to use. Fundamental principle of counting says if one if one event can be done in n ways and the second event can be done in n ways, so the total number of ways that both first this and then that is n times n. And that's all you do. So you can see this common sense. We have seen that it is 3 times 5. So in this case, the total main option is 3 times 5, which is 15 and done. I'm going to give you one more example. Let's see. Check this out. Suppose we are in Tucson and you want to drive, you want to go to Phoenix, and then from Phoenix, you want to go to, let's say, LA. Now, imagine you have three options to go to Phoenix, okay? You go by car, you go by bus, or you go by, let's see, by bike, okay? And but from Phoenix to LA, you have four options. Maybe you can go by plane, you can go by bus, okay? You can go by, let's see, you want to go bike also, and you can go by car. So we have four options. So how many different possibilities, how many different ways can you complete a journey? And one of this, I want you to see this color. If you go by car from Tucson to Phoenix, then from after reaching Phoenix, you have four options to go to LA. You can go by plane, you can by bus, you can go by bike, or you can go by car. So if you're selecting car, you have four options. Then again, you select, let's see, instead of car, if you had to go from Tucson to Phoenix by bus, then you can go again. You have four options: one, two, three, and four. So that is another four, right? And last, I'll put another color here to show the blue color. So this is the blue one bike. If you go by bike from Tucson to Phoenix, then you have from Phoenix to LA, you can go by plane, you can go by bus, you can go by bike, you can go by car. So again, and you can see there are three fours. So it means it is 3 times 4. So what does that mean? This 3 is because the first part. So there are first part was going from Tucson to Phoenix. You can go by three ways. So that's 3. So in the formula, it is m times n. That's called fundamental principle of counting. So the first step is going from Tucson to Phoenix. There are three options. And from Phoenix to LA, you have four options. All you do is just multiply and get the answer. And that's called fundamental principle of counting. Okay, let's move on to the next. So whatever I say, that is called fundamental principle of counting, or it is also called multiplication principle. So nicely shown, you can check your paper printout I gave. If you are asked to choose one item from each of the two separate categories. Now, remember I was saying from Tucson, you go to Phoenix and then go to LA, right? So separate categories means you go 3 here and then you go 4 here. That's what I mean. Where M items in the first category going from Tucson to Phoenix, and N item going second category by going to Phoenix to LA, four ways. And the total number of available choices is just multiply the two. And this is called fundamental counting principle. I call it fundamental principle of counting or fundamental counting principle, or in short, basic counting rule also. And imagine we can use this same idea here. There are 21 novels and there are 18 volumes of poetry, okay, on reading list of college English course. So in the English course, you have this option to 21 novels and 18. How many different ways can a student select one novel and one volume? Now remember, these are 21 novels, right? One, two, three, four. So this is like uh, 21. These are 21 novels, right? It's like one, two, and so on. And you have another option is the poetry. So poetry one, poetry two, and like this you have 18 of them. So the question is, how many different ways can you select? So the first one, like so two separate categories. The first category is the novel, and the second category is this the is the poems, poetry, sorry. So the first one, we have how many, what option? There are 18 of them. These are all together 18. So that means the M here is 18. And then once you select the novel from here, then you need to pick a poetry, volume of poetry here. So you have N here in this case. Sorry, the novel is, this is not, it's 21, right? So this is 21 and the poetry is 18. So the total number of the question is asked, how many different ways can a student select one novel? Let me think. So different way, one novel and one volume of poetry. So this can be done from 21 novels. So you just say, okay, 21 times you have 18 volume of poetry. So all you do is just multiply this, and you can use the calculator if you want, or you can directly do like this: 8 is a 16, then 1 and 2, and you get 8, 7, 378 option. I hope that makes sense. And as and when required, the calculator I will show you. Now, example number four is a continuation was another example that we already did. When you go to the restaurant, you have three options. That is, you have soup, salad, and breadstick, and then there are five main courses which we have seen. But then after that, we have another option category that is two choices for dessert. That is pie and ice cream. So this is ice cream, right? So the question: can we use fundamental uh, fundamental counting principle? Can we use fundamental counting principle? So what is this means? You just have to multiply the first. So the first option for this uh, is the first category is you have three choices to select, one, two, three. So you say, so question is how many different meals, the total number of total different meal. Okay, total different meals will be. Okay, the first one is selecting the appetizer. You have three options. Once that is done, then you select the main course, which is there are five options. So multiply by five. And once you are done, then you have two choices to select pie or ice cream. So you multiply two. So and you get 3 times 5 is 15, and 15 times 2 is 30 total different meals, and you're done. So simple, right? So let's move on. So question number five says a quiz consists of three true or false questions. So there is a three questions. Question number one, question number two, question number three, and each question has got either you have to mark true or false. So there are you have to select true or false. So it is going to be true or. So how many different ways can you, how many ways can a student answer the quiz? So, so in the first question, how many of, first of all, check what are the categories. The first is each one is a each category is a question. See, these are three different questions. Now the first, what how many options we have here? And you can see there are two options, one and two. So that means this first one has got two options. How many options are here? Again, you have two options. How many options do you have for the third question? Again, you have two questions. So that means all you do is how many ways can a, so total number of ways a student can ways a student can select uh, can answer is All you do is just multiply 2 times 2 times 2. And then 2 times 2 is 2. This 2 will be 4, and 4 times 2 is equal to 8. Or 2 times 2 to in the exponential form, you just write because 2 is multiply itself. So we write 2 raised to 3. So this also we are going to write this lot of stuff like this. In other words, let's put it this way. Uh, so there are since uh, so the answers could because there are three questions. I'll put so three boxes here to show the visual understanding here. So here, the first place, this could have been true or false. The first one could be true or false. So that's how I'm going to write this is true. The second one could be also true or false. This is another way to show visuals. And then when you multiply this, you get 8. But how do you really see this? Let's see if I put let's put T here. Okay, the first one is T. If the first one is T, so if the first one is, then the second could be true, and the third one also could be true. Or you could have the first one is true, second one is true, this is false. Or you could have a second one false and this one is true. Or you could have both false, the second and the. So like this, we can figure out also. So this is if the first one I select is true. Or you can select first one as false and then it will be second one and the third true. Or you can so these are all visual. You can see what I'm doing. Lot different or all false, and you can see clearly the visuals are there. These are four and these are four altogether 8. So one is the visual way of writing and figuring out. That's going to be also later on we will see it called sample way, sample space. What is sample space means figuring out all possible favorable uh, options for the question. So let's go to the next. So next example is you can check your hard copy. Suppose a particular restaurant you have 8 choices for the appetizer. Okay, then you have 11 for main course and you have 5 for dessert. See, so that means when you go and you have appetizer, the first one you have 8 choices. So this is, so I'm gonna write here. Let's see like this. So the main is the appetizer. This is the for the appetizer. Then you have main course, and then you have dessert, right? So how many options are? How many ways can you select? Is because there are 8 appetizers. So let's say these are all uh, dishes which are 8 of them. See, these are 8. So it could be the first or second or this one or any one of them. See, so you have 8 options. So that's why I write 8. And you have then 11. So that means there are another 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 of this. So this could go anywhere here. See? So all this could have been inside here. So 11, and then there are dessert. There are 5 choices of dessert. Let me see, 5 choices. So any of this could go here. Let's see. So there are 5. So all you do is by fundamental counting principle, your answer becomes A. Now, so how many different meals option do you have? The total number of different meal option is 8 times 11 times 5. This will be 88, and if you multiply by 5, you get 440 menu combinations. So I will say this menu permutations. We are going to use this word. What is the meaning of permutation? Means the order matters. Order matters means like okay, first you go for appetizer, then the main course, then the dessert. So that way. Let's go to the next. Okay, now see this example number 6. So this question says at a swimming competition there are 9 swimmers who are competing to a race. Okay, the question is how many ways can they place first, second, and the third? So what? So let me show the So let's see, these are the swimmers. So 9 means 1, 2, 3, 4, 5, 6, 7. So these are 9. Now, when they race this way, okay, so there will be first, second, and the third place. So the question is, how many ways can this be possible? So I'm gonna write here maybe the first place, second place. So this is the first place, this is the second place, and this is the third place. So if you see this, how many ways can the question is how many ways can the first, second, and the third be placed? So that means the first one, the first place, okay. Uh, so because these are 9 of them, any one of them could have been here. See, this one, two. So how many? What are the possible options you have to occupy or take the first places? And you can see all these 9 options. So that's why we say, okay, this is 9 chance. So there are 9 options to any of these 9 players could be the first place. Once one of the so out of this 9, one of them is already placed. Let's see. Let me take off. Let's see from this. Let me take off this piece. This guy is gone. So this guy is gone right here. He's gone here. Okay. So if that person is gone, of course, it could have been anyone. That's why I said 9. So once that is gone, we have, so from the, this is gone, so that will be only 8 remaining. See, this guy is gone. So that will be 8. So the second place will be selected. So second place, this place will be, there will be 8 left. 1, 2, 3, 4, 5, 6, 7, and 8. So this could be any of those 8 swimmers. See. So one of them is done. So let me take this guy done. He's already put here. Maybe he is already placed over here. This guy is gone here. That means there were 8 options. Now once he's gone, there will be how many are remaining? 1, 2, 3, 4, 5, 6, 7. So you have only 7 options left to do this. So eventually, what you get is you get to the how many ways can first place and the second, third? That could be 9 times by fundamental principle counting. All you do is multiply this 9 times 8 times this, and you end up getting 504. You can check. This is 9 times 8 is 72 times 7, and you end up getting 504. So this is the understanding piece. Uh, of doing this. And there is another something called permutation that we will see. But let's finish this. The next question. Next question says, how many ways can the first place, second place, and that if the swimmer Ariel, so Ariel wins the first place. So that means in the first section, see this one is Ariel is already in the Ariel is right there. So if these are the swimmers, 8 of them, if these are the swimmers, 8 of them, so I think I put one extra there. Okay. So out of this, one of them is Ariel. Let's see, this is Ariel. So this Ariel already wins. Okay, he's done. So the question is, if he's already done, then there are 8 left. So the first place is Ariel. So this is first place is Ariel. So only one person, his name is Ariel. So this is one. And then the remaining will be second place could have been any of these 8. See this? 4, 5, 6, 7, and there is 8 here. I think I missed that. So 8 times. And once one of them is filled up, let's see if I take the knock off this guy is already is second. So what I left is there are 7 left. So these are the 7 left. So this will be 7. So the total number of ways will be your second question here. So if the first is Ariel, and how many ways can the second and the third? So the total number of wheel will be 1 times 8 times 7, and you can see which is 8 times 7, and that is 56, and you're done. How many ways can all 9 swimmers? Now, this is slightly different. They want to take a picture since the, the tournament is over, competition is over, and there are 9 of them. Now, instead of drawing the picture, let's call this as A, B, C, D, E. These are the names of the first letter of their, maybe like so H, 1, 2, 3, 4, 5, 6. So on if I want to keep the take a picture of this or take a photograph, how many different ways can you do this? Now remember again, you use the fundamental principle of counting. So the first place could have been any one of this. So these are 9, and you want to put them on the like this. You want to put them in the in 8 places. So the first one could have been so this. So this is the first place, right? The first position could have been 1, 2, 3, 4, 5, 6, 7, 8. And oh, 9. There is 9, right? So this is 9 HI. So it could be any one of this 9. So this will be 9. Then once that is done, the next position will be, that means one of them will be gone. So there will be 8 remaining. So that this will go 1, 2, 3, 4, 5, 6. I think I missed 1, 2, 3, 4, 5, 6, 7. Yeah, 8. So this will be so 8 like this. And after that, you can use pink color, let's say. So let's knock off this guy. So there will be 7 of them left, right? So from there you can pick 1, 2, 3, 4, 5, 6, 7. I think you guys got an idea what I'm saying. So all you do is go and multiply. The fundamental principle of counting says all you do is just multiply 9 times 8 times 7 times 6, 5, 4, 3, 2, and 1. So you multiply all this and you got multiply and then multiply by 1, and your answer is going to be ending up, I think it is 362, 362,880. So that's the answer. Now you may say, how do you can use your calculator and get, but there is a shortcut trick that we need to use now. Now, what is this basically? Instead of writing all these pieces so many times, we use something called a factorial. So what is the definition of a factorial? They gave us here with the exclamation mark. Can you see this n factorial? I'm going to use some examples to make you sense what is the meaning of that. So in this case, because I'm starting with that 9, so if you start with 9, your n is 9. So this n is 9. So you just put 9. And because you are going on decreasing, so this n minus 1, you reduce it by 1, then you reduce another 1, so it goes down. So it's going on reducing by 1, 1, 1. And that's called n exclamation mark means it is 9 factorial. Now, I want you to see on the calculator also, how do we find this? And one more thing you have to know also, if it is 0 factorial, we get 1. So let me see what I'm talking about is, let's see, let's imagine if there is a 6 factorial. So what is 6 factorial? Basically means it is 6 times 5 times 4 times 3 times 2 times 1. That's it. That's all it means. What is the meaning of 4 factorial? It means it is 4 times 3 times 2 times 1. So you already understood what I'm talking about. If it is 5 factorial, it is 5 times 4 times. If there are 5 students for a picture, and you just have to multiply that. See, 2 times 1. And but we can also write this 6 factorial. Watch this. This I can write 6 times 5. And the other one I can group this. This I can group and say, okay, this is 4 factorial. So that means 6 factorial can be written as 6 times 5 and then 4 factorial. So one more example may be, uh, let's see, there is a 9 factorial. Okay. Now I want you to write, maybe I want to go reducing by 3 times. So it will be 9 times a times 7. So I reduce 3 times, then it becomes 6 factorial. See? So 1, 2, 3. Or if there is a 12 factorial, and I want to do it 4 times, so it will be 12 times 11 times 10 times 9. So 1, 2, 3, 4. And then you say 8 factorial. Otherwise, also 12 factorial is 12 times 11 times 10 times 9 times 8 times 7, 6, 5, 4, 3, 2, and 1. So you can just put this as together, and that is 9 factorial. This is 9 factorial. So the first four numbers stay the same. So it is 12 times. So as and when why we require is this, suppose we seen this, there were 9 swimmers and we needed to know how many permutations. So that's what the word is, how many different ways it is possible to, when you mix the swimmers to different pictures, right? You want to have we have 9 places. So how many different photographs can you figure out? That's what is called permutation. So what is permutation means? Where the order matters. What does that order matter is swimmers, which position a swimmer is standing. So either here, first place, second. So that's the meaning of permutations. And we'll see this now. Let me show. So you can check the next example. Says how many ways can 5 different door prizes can be distributed among 5 people. So there are, let's see, these are one, two, so these are 5 people, right? So, and these are 5 door prizes, right? So these are door prizes. So these are door prizes, right? So door one, two, three, four. Now the first door prizes could have been gone for the A, B. I can call them A, B, C, D, and E. So this could have gone any one of them. See, so they have 5 options. So this is 5. So the first one is 5. Once this door prize is already given, maybe it is gone to this guy, so I'll take him off. So, okay, so this is gone. So, so now you have 4 of them are left. See? So now you have 4 door prizes. One, two, three. So this second door prize could have gone to this guy or this guy or this guy or this guy. So how many ways it is possible? 4 times. And you can see this is 1, 2, 3, 4. And let's see the second door prize is already gone. So let me take this. This is gone, and this guy gets it. So you have 3. So you have 3 door prize. Uh, 3 are left. So this door is the third one. This is the third door prize. Could have gone to this guy or this guy or this guy. So there are 3 ways. Once that door prize is given to one of them, maybe this guy. So 2 are left. So the next one, this piece can go to here or here. And that's why you multiply 2. Let's see, it was gone to this guy. So what is left is only one door prize and one person. So he will get he will get this price. So that is multiplied by 1. So there you're going to get 5 times, 4 times, 3 times, 2 times 1. Because these are small numbers, we can easily multiply. 5 times 4 is 20, and 20 times 3 is 60, and 60 times 2 is 120. So how do we use the calculator? Remember, because of the factorial definition, we know this is 5 factorial. See? So if you go to your different ways, I'm using the Desmos calculator here. Open a new tab on your laptop, click desmos.com, and then you go bottom. You can see there's a scientific calculator. Click on it. I'm going to show you in the class. Okay. So now we want to know. So click on this function, right? So click on this function, and you will see there is a factorial. If this is a factorial, so that's what. First of all, you need to put the number 5, which I forgot. So I'll put a 5 there. So that's the 5, and then click on this and enter, and you can see clearly there's 120. We are also going to use something called permutation NPR. And what is that NPR? We'll see. We'll take one example and understand. And I hope so. We are going to use these three pieces: NPR, NCR, and this factorial in this lesson. Uh, so whenever there's a permutation where the order matters when you select, we're going to use NPR, NCR. So let me show straight away with the example. Okay, so here it is, the definition. A permutation of set of elements in an ordered is an ordered arrangement where each element is used once, or we can say without replacement. So two ways can say it, once or without replacement. That means you have, let's say there are three blue marbles and there are four red one. I can see. So if you select one, so you want for you, if you get maybe blue. If you get blue, then you get $100, and if you get this, you get 70. So the order matters whether the first ball or the second one. See, so permutation basically means it's a set of arranging this two. In this example, I'm using these two marbles. Let's see, the blue and the red. So the first one, uh, so the order matters. If I put the blue one in the beginning, let's see, if I want to put a blue here, you're getting $100, right? But if you pick a red one, if you pick a red one, then you get 75. The order matters. So what this basically means is uh, to find the number of permutations of R objects from N objects, we can use now something crazy formula. Let's see what is the meaning of NPR. Some of the calculator they use P first, then N, and then R like this. So it means the same thing. What this basically means is N stands for the total number of possibilities. Let me use little example. I think that way you will get. So let's see. Let's think that in the classroom. So I have, or we can think of the same example. I have 9 swimmers, right? There were 9 swimmers. Okay, and then we had the first position, first place, the second place, and the third, right? So from the 9, you need to get how many different ways all this wins possible: first place, second place, and the third place. So instead of remember last time it is 9 times 8 times 7, right? That's how we got the answer. But we can use this new formula called permutation formula, and that is because there are 9 swimmers, so we say okay, n is 9, and then what does this R stands for? R is you are going to fill the first place, second place, and the third place. So the R is 3. So how many ways this is possible here? And that's why we do use the formula, this one, and the formula is NPR. So NPR is ratio of n factorial. There it is. And then subtract the R from this, and you get this. Now, when you do this, let's really get this. What I'm talking about is you have to understand this. Is let's do this swimmers problem because there were 9 swimmers. Remember, there were n is 9 swimmers, and you need to see how many different ways can they win the first, second, and the third. So we saw that the R is 3. So if I want to apply this formula, so it is 9p3. So this becomes a ratio of 9 factorial divided by 9 minus 3 factorial, and that becomes 9 factorial divided by 9 minus 3 is 6 factorial. Now, what I do the next is the 9 factorial which is there, the 6 factorial I'll keep as it is, but the 9 factorial we can reduce it and say, hey, 9 times 8 times, if you remember, I showed this 7, 3 times I do, and then I can write 6 factorial. So you can go on reducing, and then eventually You see there's a 6 factorial in the numerator and the denominator. So this and this crosses out. See, they are the same. What are you left with? 9, 8, and 7. Is it not the same thing what we did earlier also for this? Earlier we did 9 times 8 times 7. Now, so this is how you do this in manual. This is called manually. Okay. And the answer is 9 times 8 is 72. And this is 72 and 7 to the 14, 49, and you get 504. Uh, so let's check with the calculator. If I see here, let's go to the Desmos. If you go right here, and let me take this here on this side so you can see. Now I need to click on the function. You can either use the scientific calculator, two different ways. I think let me, I don't want to confuse you. Again, I want to show desmos.com. I'll start fresh and you go down. There is a scientific, click here. Okay, here. Then click on the function. In the function, you can see there's an NPR right here. So click this NPR, put a 9, comma, 3, and you get 504. See, so simple. So that's how you're going to do. Or you could say, okay, you want to do first uh, 9 factorial. You could also do, click here, 9, and then again go to the function, click factorial, and then you want to divide, click main, divide. So this divide, sorry, I made a mistake. Since, yeah, divide, you can put 6 factorial also. So you put 6 and go to the function. See, you get the same answer. So as we progress, we are going to do shortcut like this, quicker way to do. Or if you want to use, you can use this way also as this. Click on this and click on the open graphing calculator, and you can start here. And there's a keyboard right here, and you can try see the same thing. If I want to find 9PR, you just go on all the way down, and it will show up. Will show up. Uh, uh, should be showing now. I think I should put statistics first. Hmm. I think you have to go all the way down. Here it is. NPR. So put a 5, then comma, the comma, sorry, not 5, 9, right? So 9, comma, and you click on 3. There you go, 500. So if you guys get confused with your calculator, I will come and help. Don't worry. Let's move on. Okay, let's see how to use this. So in example, I have 9 paintings. So how many paintings? These are 9 paintings. Okay, now from this 9 painting, he's trying to, and he has and have a room to display only 4 at a time. So if this is his wall, so he has only 4 to be put. So these are the 4 places he can. So the question is, these are 9. I think you got an idea what I'm talking about, right? The first place could have been, so the first, this one, second. So, so how many different ways could I do this? Now remember the first one could have been any one of the same thing I'm showing. See, any of this 9 picture would go here, right? So that is 9 times. And the next one is 8. The next one is 7 and 6. Or you directly use the formula, permutation formula. What is the permutation formula? You have n is 9 and your r is uh, so you want to, from 9, you need to pick 4. So those could be any 4 places. So your R is the 4. So you use permutation with the 9 on the left and the 4 on the right. And using the Desmos, you just put that in the calculator. Or let's do it really the actual work. So this is 9 factorial, and you subtract the 9 and the 4. Okay, so that way you get 9 factorial over 5 factorial. Yeah? And this becomes equals 9, 8, 7, 6, and 5 factorial. I got all the way to 5 factorial because in the denominator there is a 5 factorial which we can cross out. So what I left is only 9, 8, 7, and 6. And if you do this calculation, now we can use the calculator also, but I wanted to get time. This becomes 3024 permutation. These are total number of permutations. Means the order matters which one is first or second and the third and the. So how do we use the calculator? Same thing I already shown you. You can you can click here and let's see if I want to go to the next one. Click on the function and go all the way down and then put 9. So put 9 comma 4 and you get the answer. See? So this is how you do it. Uh, or you can use the other calculator also here. See? So you can do the same thing. Click on the function. Oh, here it is already there. So n and put 9. So put a 9. Main is 9. 9 comma. Just a comma. And get the answer. Okay, let's go to the next. So example number 9.1, how many ways can a four-person community? Four-person means your R is four. So that means president, vice president, secretary, and treasurer be selected from 16 board of directors. I mean, this is your end, right? So there are 16. Let's see, there's a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 14, 15, 16 members. These are from this 16, you need to pick the four places. So these are the four places, or you can put this way also, like this way. I like to write like this so that we can multiply directly. And you can see the first place, president. President, then comes the vice president, then the secretary, and then the treasurer. So the first place could be any of this one, or it could be two, or it could be three. So there are 16 options, right? So once one of them is done, let's say this one, you have 15 options. Once the vice president is taken, there will be 14 left. And once the secretary is put, there will be 13. So basically, you are doing 16 times, 15 times. So this is called fundamental principle of counting, or you can use the formula. So I'm going to use formula here. What is the formula? So there are 16 of them, and you want to permutation possible. How many different ways can you do? Select president and all this four. So you just do this, put on the calculator. Of course, using the formula, this will be 16 factorial over 16 times. The bottom piece will be, you have to subtract. The formula says you need to subtract 16. What is the formula? N factorial divided by n minus r factorial, like this. So that means 16 minus 4 factorial. And this answer will be, now because 16 minus 4 will be 12 factorial, so I can reduce this 16 factorial until 12 factorial. So we can easily cross out the this 12 factorial. And this is back to the same fundamental principle counting, right? Now the question is there a shortcut to do this? Yes, we have those. We look at this calculator here. We can easily uh, start a new one and say, okay, go to the function. When you go to the function, there's NPR, put the 16, comma, and just put 16, comma, 16, comma, how many we, 4, right? Yeah, there you go. So you get 43,680, 43680. So you get, so this answer is 43680. So that's all it is. So two different approach. One approach is using fundamental principle of counting, or the second one is using the permutation formula. So as we continue like this with more and more, I think we'll get an idea. This is also the next question is you see this is a beautiful example of alphabets. Now, how many five character passwords? So you want to create a password which is five characters. So we need to fill first, second, third, fourth. Now, from the letters A to Z. So we know the letters from A to B to all the way X, Y, Z. There are altogether there are 26 of them, right? Now, among these, which are the vowels? So, what are the vowels? Vowels are A, E, I, O, U, right? A, E, I, O, U. So, there are five of them. There are five vowels. And what is the meaning of consonant? Oh, they're not asking this question. So, how many ways can you pick if if repeats are allowed? It means you can have a password with it A. This could have been your password. This is what that repeats allowed. So that means to fill the first one, and the first one, so the first character. So these are also characters. Okay, so there are 26 options to fill the first one. So the first one can be filled in 26. Once that is done, we can use the fundamental principle of counting and say, okay, the next one, because there is a repetition, what's this rep? So the next one also is 26. The third one also is 26. The fourth one also is 26. The fifth one also. So if there is a repetition allowed, we can write this is 26 raised to 5. And if you use the calculator here, see, you put here, and let's put here and then enter and take a new one and put 26, the main, 2, 6, and go raise. So this is the one you go to the exponent. So here, click here, and you so it's a 5 letter, right? Put a 5 and you get the answer is 11,008. So this is the answer. You get 11,881. So the answer is, let's go over here. So your answer is going to be, this answer is going to be 11,881,376 possibilities. Now the second question is if no repetitions is allowed. Now what is that? No repetition basically means uh, if there are 26 of these pieces, right? The first can be any of those 26 pieces, characters. So once the first one is placed, is already used up. Let's see from here there is a E, F, G, and so on. So let's see the F is placed. So of course it could have been any of these 26. So I'm gonna take off this F here and put it here. So that's the F. So you had 26 options. Once that was done, so this F is gone. Then you have ones. So how many are remaining is you will see there will be, so one is already taken, so there will be 25 remaining. So the second character can be placed in 25, you see. And the next one will be 24. The next one will be 20. I think you've got an idea what I'm talking about. Just multiply all these pieces and you get the answer. So this is one way to get the answer. Or another way to use is this is fundamental principle of counting. Or you could use the formula. And what is the formula? So you have 26. 26 is the n, and you have 1, 2, 3, 4, 5. Your r is 5. So the total number of permutations possible or different ways you can create this password is 26p5 like this, which is 26 factorial, and you subtract 26 minus 5 factorial like this. Then you can write 26, and because this will be 21, I can go all the way like this. Okay, and you may say, do we have to write all this? That 21 factorial will cross out that bottom piece, and eventually you get all this until 22. Now we'll avoid this and use this as the calculator since we have already understood what's going on. So we just click on the calculator here and put an enter maybe and go to function speed. So you have 26 here and then you click on the comma and then you have 5 and you get 7,000. So you get 7 million. If we go there, uh, so the answer becomes 7,893,600 total number of possibilities. So different ways you can create this password with the 5-letter password with no repetition. So each one will be different. Each of these letter will be different. And I hope I'm making sense. Let's go to what is the meaning of uh, combination. So this is example number 10. A group of four students. So that means this is your R. Remember, this is your R. Is to be chosen from 35 member class. So that's the N to represent the class on the student council. Okay. So how many ways can this be done? That means you need four students, one, two, three, four, and these students you need to get from a group of 35 members. So there are one, two, three, four, five. Like this, there are 35 of them. So so how do we do this? All you do the same thing, the formula by combination formula. The combination formula says it is NCR. Here N is 35. C, and you have four students, so it is 4 here. So what this means, you could write 35 factorial divided by R factorial, which is 4 factorial, times, and now you subtract. Okay, so you subtract the 35, that's total number of students, minus 4, and this is 4. I'm showing all the steps here, but eventually we are going to write shortcut. And this will be 35 factorial divided by 4 factorial. And if you subtract this, this becomes 31 factorial. Now, the top number we can reduce. How do I reduce this? Because the down number, there is a 31, the numerator we can write as, so the numerator can be written as 35 and then reduce it by 1, so it becomes 34, 33, 32, and right until 31 factorial. So why did we write this? So that we can cross out 31 factorial and 31 factorial. I'm sorry, this is 31 factorial. So what are you left with is 35 times 34 times 33 times 32 and then divide by this 4 factorial means 4 times, 3 times, 2 times. Now you can put this in the calculator, the top part, whatever this answer is. So this is the numerator separately you can do and work it out. But what we will do is directly use this from the calculator 35C4. So if I go click here and go to the calculator, not this one. You can use any one. I think I'm going to use the other one, the scientific calculator. So this is the best. So this time you're going to use function, and this time you're going to NCR, and there were 35, and then you click on comma, go to main, and put comma, and you needed 4 of them, right? And you can see combination 52,360. So go back here, and get the answer is 52,360 combination picking 4 students from 35 member So that these are the number of combinations, and you're done. That's it, not much. This is 11.1. A fast food restaurant offers five side dishes. So that's the main one. That means your N is five. Your meal comes with two side dishes. So how many ways can you select your side dishes? So that means there are one. These are like five dishes, right? From here you have to select two of them, right? So this is where you want to sit with this table. So you can have option. I can call this as like say A, B, C, and D and E, right? You could have select this first one as either A and B. So this could be your first combination, or you could have select A and C, or you could have done A and D, or you can A and E, and then after that you could do combination of let me use other color pink, or you could have used B and C, or B and D, B and C like this. So there's another. So the first one was there were four, one, two, three, four. Then I use the B and you have one, two, and three. And then I'm adding, let me use a green color to show. So one, two, see. And then I can have last option is this, plus one, see. So 4 plus 3, 7 plus 3 is altogether 10. Now the question is, are we supposed to draw this? No, we will do directly. And what I'm talking is what you're all you're supposed to do is your n is total options you have is 5 and you need to pick 2, so your r is 2, and doesn't matter which one you're picking, the first or the second. How many ways can you select your side dishes? So so this is about two dishes, right? So your r is 2, so the combination is number of combination is C and R, so then you put 5 C 2, and you'll see if you do this. Of course, you can use your formula also, that is this way, 2 factorial and then 5 minus 2, which is 5 times 4 times, why I wrote like this. And 2 factorial basically means just a 2, and this is 3 factorial. And you can see this crosses out. And this is 5 times 4 is 20 divided by 2. But since we can use the shortcut, we'll use that. In the calculator, you can just put 5C2 and you're going to get up 10. And then the next question is, how many ways can you select three side dishes? So again, this is 5. C, you put 3 because this is R is 3. And you also get 10 answer. And somehow in this problem, you see that this answer and this answer, why they are same? It's because there's a combination formula like the NCR is same as NCN minus R. So that's why. And you can see here that 5C2 is also same as 5C of 5 minus 2. And if you see this, is 5C2 is 5C3. So it's the same thing. Anyway, if you get confused, don't worry. I just wanted to show you that this is also a formula. If you go to advanced classes in statistics, you'll learn more of that. Okay, next is in example number 11.2. More examples. United States Senate Appropriation Committee consists of 29 members. This is the main big one, which is 29 members, which is also I can put like at the end. The Defense Committee of the Appropriations consists 19. That means from here you have to select 19 like that. So from this 29 members, you're going to select 19 members on the subcommittee, defense subcommittee. Now, disregarding party affiliation means like the main 29 members, whether they belong to a Democratic or the Republican, doesn't matter. The question is how many 19 members subcommittee may be chosen from among the 29. So it's the same thing NCR. Okay, the order does not matter, it's just a combination. So it is 29 total members is our N is 29. Put a C and a 19. Put that in the calculator and you get the answers. If I put here dashboard.com and here scientific calculator, input, go to function and put C's and put uh, 29, sorry, so it is go to the main, type in 2929, comma, and then you want 19, right? 19. So you get 20. So your answer is going to be 20,030,010. So these are the total number of combinations, different ways you can select all these 19 members. Let's go to the another one. Now, this one is the same question, but this time instead of 29, remember there were 29 in the United States Senate Appropriations Committee, but these 29 members, there are 15 Republicans. I'll break this. There are 15 Republicans and 14 Democrats. So these are Republicans. There are 14 Democrats, right? Now, the question is when you select the committee here from here, this one, there is a condition that so you have a condition saying that you are going to pick 19, but this 19, 10 has to be Republican. That means here the 10 has to be Republican and the 9 has to be Democratic. Uh, so what that means is you first, let's see, let's figure out only how many different combinations are possible. How many different ways can you select 10 Republicans from 15? So there are two steps here. Steps number one. So you need to select 10 Republicans from 15 Republicans. See? So that means again it is a combination. So all you do is your 15 is like N and this is like R. So it become NCR, which is 15C 10. And if you put on the calculator there, we'll get the answer. We'll see that after. What about the Democratic? Now this Democratic, you need to have 9, and this has to be from the 9 Democrats from 14, 14, 14 Democrat, right? 14 Democrat. So that means this is your R, this is your N. When you write down NCR, so it means there are 14 Democrats, and from this you are picking 9. So if you do this formula here, work on this NCR and 14. So these two pieces we can put on the calculator here. Okay. So let me take this off and start a new one. Click on the function NCR, and we wanted 14, right? From 14, sorry, from 15. So it was 15. We needed the Republicans of 15. So type 15, then comma, and we needed 10 of them, 10 Republicans. And you get the answer is 3,000. So this is what you get. And also we'll do the other one and then put together, go to the function and then NCR. This time you have from the 14, we'll go to the main and put 14 and comma, and you are picking 9 Democrats and you get this answer. See? So these are the answers you can remember 3003 and 2002. Go back there and you can see. So this answer you got 3003 and this answer you got 2002. All you do is just multiply the thing. So the total, so the question was how many different ways can the members of the Senate Defense Subcommittee be chosen from 29 senators? So your answer is going to be this one. Actually, it is 15C10 times this one, which is 14C9. And you can see that it is 3003 times this one goes 2002. And you end up getting 6,001,2006 possible ways of selecting the defense. And you can see using the calculator also. If you see go here, if I want and I just multiply 303,003 multiply by 2002, and you can see the same thing, 6,012,000. So, or you could also do that another way. Why can't we do directly multiply these two pieces also? You can put these NCR and you can say, okay, type in 15, comma 10, and then multiply. So this you multiply this directly, and you can write again, go to the function and then this, and put 14, comma 9. You get the same answer. So this is also is correct. So just as you get used to this, you will understand. We'll do the more problems we do, we understand better, right? Okay, look at this. So the question is asking, is this combination or permutation? The question says, how many ways can you select 5 free toys from a bucket of 200? So that this is the bucket, then there are altogether toys here, which are 200. And how many ways can you pick 5 of them? See, it doesn't say which first, second, third. So this is like 5 of them, maybe like this. You want to put them 5? Doesn't say. So all you do is this is like combination. So there's no order there. It doesn't say with replacement or does not say uh, whether order matters. But in the contestants of 1,000 players, and how many ways can you finish 3? So that means if there are 1,000 players, and from here, when they go for running, you go first place, second place, and the third place. Here the order matters. Can they finish? First 3 finishers come first, second, and the third. So order matters here. And because the order matters, this is called permutations. I think doesn't make. Let's do the exercise problem. So if you see the exercise problems, all is the same thing, more practice. If you see the first one, so this is what can come for the exam, right? A person owns 4 pants. Look at this. They have 4 pants, 8 shirts, 2 pair of shoes, and a jacket. How many outfits can they wear to school if they must wear one of each? That means a person has to select, right? So the first one, that means he selects pen, right? So in this example, we can use the fundamental counting principle. I call it this, or you can say principle of fundamental principle of counting. So here, the first one we have 4 options. Eh? So now I'm gonna make a like this so that okay. The first thing is you have to select pen 4 pairs. So this could have been this could be 4 options. See, next you have 8 options. Next you have 2 options, and next you have 1 option. So basically, what all you do is just multiply 4 times 2 times 1, and you will get 32. I think this is 32, and this becomes 64. Okay. But if you want to think that in a nice formula ways, the first one, honestly, the first one you're picking. I just wanted to get an idea what's happening here. The first one, there are 4 pens and you select one. So it means the first one you are selecting 4 P1. The second one you have 8 shots. So it is 8 P1. It's like multiplying this. The next one you have 2. So it is 2 P1. So because you are selecting only one, right? That's why it's 1, 1, 1. And there is one jacket, so it is 1 P1. So another way to say is I think this one P1. And it's the same thing actually. When the formula always says if you have NP1, it is just a 1. It is just a N. So this is like a formula to be remembered. Even for NCR, if you have NCN, so this answer here is N. I'm sorry, this one for combination, it will be just one. That's the this is one, NCN is one, but NP1 is N. So that's how it is. So this also is correct because we are going to use this formula in the later examples how it works. So the same. So at a restaurant we have three appetizers, four entries, two desserts. How many three-course meals you have if you have a you must choose one of each. So the first one you have three options. The second one you have eight options by fundamental principle of counting. You just do maths and you get 24 times 2 is 64. Uh, sorry, 3 times, yeah, 48, right? So you get 48 and you're done. Or you could say also the first one could be 3P1, the second one is 8P1, and the third one is 2P1. Put on the calculator, get the answer. So how many three letters words? Now remember you have to have three letters, one, two, and three. Now from this, there are four, N is four here, right? So the main thing is about this when repetition of the letters allowed is one question. So here we can't do anything. If it is allowed, all we can say is there are four letters one, two, three, four. The first one could be any of the first four. See, any of these four will go. And same thing here. Any of these four will go here. And then any of these four will go here. See? So it is 4 times 4 times 4, which is 4 cube and becomes 64. But the problem is if it is a repetition of the letter is not allowed, then it changes, right? So that means then we have a permutation. What I'm saying is you have three letters from this four, F, G, H, I, right? So the first one can go any of the this. It could be F, it could be G, it could be H, it could be I. So you have four options. So when one of the four is gone, let's say this is gone. So you have three options left. So this is gone. So now you have three. So the next one will be the second. So the next one here will be this one because this is already gone. I put a G. Let's see. Okay, I took it off. Now you have one, two, and three options. See, and then you have once this is gone, maybe H here. So you have two options left, one and two. And you have fundamental principle of counting. You just have to write 24. But can we use directly the permutation formula? Yes. So you have four letters, four, and you're picking three at a time. So three, put on the calculator and you get the answer 24 and you're done. So simple, okay? Let's go to the next. So how many four letters? Now this one is asking for four letter word from six letters. So this is our n equals six. You're asking four, right? Now, if the repetition of the letter is not allowed, that's become the permutation. Okay. So when I'm talking about permutations, basically means the order matters. So when you have four of these, one, two, three, and you want to place six of them, all this could have been any of the see. So all these six options are there. So basically it is like six times, five times, four times, three, right? This is using fundamental principle of counting, but you could use also the permutation formula, which is NPR. Actually, it is n factorial divided by n minus r factorial. But we can directly write, okay, there are six of them, P, and there are four. Put on the calculator. I think you end up getting 360. But this one is a little confusing because we can't use permutation and we can't use NCR and NPR. This won't work because this is repetition allowed. Look at this. So what that means is, so it means the first one could be, so out of these six, of course, it can be one, two, three, four, what I'm doing, 5, 6, right? Okay, I missed this one. So there are 6 ways. Then after that, the second one, because repetition is allowed, it says you can do that same thing again. So again, we'll have to do this 6. We have this can be A, E, B, W, D, P. So there are 6 options. And likewise, you have 6, 6. So it is 6 times 6 times 6, which is 6 raised to 4. And if you put on the calculator, you end up getting 1, 2, 9, 6. I hope that helps. So these are the number of permutations possible with the help of if there is a uh, option. All of the license plates, the all of the license plates in particular state features 3 letters. So you have first 3 letters, so that means here. So you have this way. So this has to be letters. This 3 has to be letters. Okay. And the next is like the all the numbers. So it can be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And it means there are 10 of them. The question is how many different license plates are available in the motor vehicle department? Now the letters altogether, how many letters are there? You know there are 26 letters, right? There are 26 letters. That means, uh, does they say that it is now? So the first, it doesn't say if the letters, whether the letters should be repeated or whether they are repeated or not repeated. They do not say nothing about it. So we can use repetition. That means the first letter could be any of the 26 letters. Then the second letter also 26, and the third also is 26. Once that is done, you can pick any of these 10 numbers. So this could be 10, 10, 10. Because it does not say that the numbers or the digit has to be different. So all you do is multiply all this 26 times 26 times 26 times 10 times 10 times 10. Put on the calculator. This will be 26 raised to 3 and 10 raised to 3, and you end up getting. So when you go use this, and I'll just put here, and I want to put 26 raised to 3, so put 26 in time, go to the main, 2, 6, go click this one, go up and put 3, then right click, and then times, then you have 10, go up, put a 3, you get the answer. So you're getting 17,576,000, right? So when you go back here, so this answer is going to be 17,576,000. I hope this helps. Okay, so let's go move on to another one. A computer password must be 8 characters long, so that means this will be 8. How many ways it is possible if only 26 letters of the alphabet are allowed? So what does that basically means? Now there are 26 letters, right? And does not say they should not be repeated. So repetition is allowed. It means you can have the first one from 26. Once you've done that, you can also have the second one from 26. And like this, it will be 26. How many times? 26 raised to 8. You put on the calculator, we put, okay, let's see here, and enter and go here. 2, 6, go up and put an 8. You get the answer. And you get almost like, even though they gave you that, that means you're multiplying, moving the decimal so many places to the right. So it's going to be 2,208,000,000. So what that means is, so what when the calculator does this, so you may be saying, hey, how do I write this? So let's do this. So 2 raised to 6. So that is like 208,827,064,576. So the calculator was showing to you, I think it was showing, it depends on 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I think it said 2.08827064576 times 10 raised to 11. So that's like a, this is the way how it's called scientific notation. The calculator does it like a scientific notation. So what is scientific notation? Basically, you always have a decimal, and before that you have to have a digit which is other than zero. It can be 1, 2, 3, 4 till 9. You can't have a zero. There has to be a number. So the calculator does that. But just start word of showing this answer. So a pianist uh, plans to play four pieces. She's a piano pianist, and there are four four pieces to her. How many ways can she do these pieces in a? So she has, let's say that these are the pieces, right? There are four pieces. She has to, when she goes on the stage to play the piano, so this is the piano, and she's sitting and playing the piano. She could play, the first one could be any of the four, right? So it could be this, the first one. And once she's done with the first, then she wants to play the second one. That could be any of the remaining three. And it's the same story which we've been doing 12 times, we get 24. Okay, so how do we use the permutation formula here? And the formula is she has four pieces and she's using all four of them, right? It's like there are four friends and you want to check how many ways can they take a picture. And you can see it means there are four friends and you move around all four of them. So what you end up getting is 4 times 3 times 12, 24. You can see the calculator does the job. Okay. So the same thing here also. It is basically the first one takes 4, 3, 2, 1. And got the answer. Or you can use this also. So you can use fundamental principle of counting, or you can use the formula. End up getting the same. I think I can skip this because they're asking you first, second, third prizes from 200 and con. So this is N and this is R3. And so all you do is N P R, which is 210 P3. And you put on the calculator, you get 9,129. So you can always check this because I'm skipping this because it's almost the same thing we are working on. Let's move on to something different. So the seven Olympic sprinters are eligible to compete with 4 into 400 means like this. They may start here. The first person The first person runs till here maybe. Then there is another person, he'll run till here. Then there is another person, then he'll go till here. And the relay is complete when you come back. So placing them is very important. Who is going to be the first, second, or third? How many four persons relay teams can be selected from? Seven. Now there are seven of them. See, these are altogether seven sprinters. And you have to select out of the seven first place. Let's see if I want to select the first place here. This is the first place, second place, third place, and the fourth place. So the first place can be any of these three, any of the seven, right? So it's the same thing like, okay, then once you do seven, 1, 2, 3, 4, 5, 6, 7, 6, 5, 4. You do the maths and you know. The main thing what I'm talking about, if there are seven, and you want to select 4, this is how you use the permutation. Put on the calculator and you get the answer. And I don't have to do it again and again because I already did it so many times. So you put here and just do your regular, go to the functions, NPR, I think I put a new one. Enter. So it is function NPR. We have seven of them, comma, and then put four. You get the answer. So 840. That's all it is. So go back to your problem, 840. So there are 840. So two different approach to do using the fundamental principle of counting or using the formula, the permutation formula NPR. And you don't have to do all that. I know the formula is like this, n minus r, but now since more important is can we apply it? That's why we use directly. To go to the next question, it says a computer user has downloaded 25 songs, see, online sharing program, and wants to create a CD-ROM. CD, olden days we have the CD-ROM. So this is like a CD now. I don't know, not many use CD. So the CD-ROM, I remember, I think it was about 700 and something a movie would go to gigabyte, sorry, megabyte, I think. I forgot, whatever. Anyway, if the order that songs are selected on the CD-ROM is very important. I want you to underline this because this means permutation. Your order matters. How many different CDs could be make from 25 songs? So you have 25 songs and you want to make out of 25, you want to have how many? I forgot. Because it clearly says 10 songs. So that means your R is 10. All you do is the same permutation formula P N R. It means there are 25 songs and you have to select 10 of them. Put this on the calculator and you're done. So there's nothing to do there. So the answer becomes 11, 11 trillion 861,676. I mean, 11 trillion 861 billion 676,288,000. So let's check. Really, it is true. I don't know. Put on the calculator. There's the calculator. I have to do this. And you need to put 25, comma 10. See? Wow. It gives in the scientific notation. Basically, when you multiply this, so basically when you multiply this, see, what's this? This is called in the scientific notation. So what is this 10 raised to 13 means you have to move the decimal. So the decimal is 1.186166763. So you have to move the decimal 13 places to the right. So you have to go 1, 2, 3, 4, 5, 6, 7, 8. Then you have to put another 0 and go 9, another 0, 10, another 0, 11, 12, 13. And you can see how it works is you get 11861676300. You have 6 zeros. 6, 3, 0, 1, 2, 3, 4, 5, 6, 3. So when I really want to check on, let's see here, this is like thousands, right? This is another one. This is another one. This is another one. And